You need to know this before we get into it. What are particle accelerators? The Large Hadron Collider, LHC, at CERN is basically a massive 17-mile wide ring of extremely strong magnets. It's the biggest, baddest particle smasher, the strongest we've ever built. It can almost recreate the universe's first moments. Could this machine, built to find the universe's secrets, hold the key to even bigger stuff? CERN, which began in 1954, is a leading research facility with 23 countries involved. Tons of scientists work there. It's a hub for brilliant minds to come together and invent things. The LHC is CERN's superstar project, but it's just one component of a huge setup of particle accelerators and tests. Think of it like a racetrack, but for tiny particles. The LHC makes protons go super fast, almost the speed of light, then crashes them together. This makes energy like what was around at the Big Bang. The temperature suddenly soars much higher than the sun's core. Magnets keep the protons on track, and special coolers keep things colder than space. The beam crashes at 4 spots on the ring where the particle detectors are: ATLAS, CMS, ALICE, and LHCb. These examine distinct aspects of particle physics. They're like giant cameras that take pictures of the crashes. Researchers study the leftovers to find stuff like the super-rare Higgs boson, or God particle, and other particles that could show us how the universe is built. By looking closely at the tiniest components, we learn about the entire cosmos. But every time we figure something out, a new question pops up. With each find, there's a new test. The LHC is not just a science tool. It's proof of human curiosity and our drive to understand how the main forces shape the universe. But as we push the boundaries of what we know, we also have to think about the ethics of it all. What could go wrong with poking around in the unknown? Could we accidentally unleash something we can't control? At CERN, where they're always testing the limits, something has come up that's got even the scientists worried. Brian Cox, who used to work at CERN and knows a lot about particle physics, said something that got everyone talking. He mentioned that the LHC intends to produce a mini Big Bang, a small version of the event that started everything. Cox also talked about what this could mean. He said the LHC could help us make huge discoveries, like understanding the Higgs boson and dark matter, the mysterious stuff that makes up most of the universe. Imagine having the power to create the matter the universe is made of. Sounds amazing, but it's super risky. This mini Big Bang isn't just a theory, it's real heat, pressure, and energy, like what existed when the universe began. It's like being there at the very beginning. But with that kind of power, we have to be responsible. What if something messes up? In fact, in 1978, something did. A Russian physicist named Anatoly Bugorsky suffered a terrible accident while working on a particle accelerator. A beam of protons hit him directly in the head, entered on one side and exited the other. He stayed conscious and even walked to get help. Though he survived and could still think clearly, the beam destroyed some tissue. He lost hearing in one ear and suffered lasting facial injuries. This shows how powerful and dangerous these machines are. We can't downplay the risks of a particle smasher like the LHC. There's a chance of weird reactions and of messing with the fundamentals of everything. This isn't just sci-fi movie stuff. Real scientists have said they're worried. One of the scariest theories about the LHC is that it might create a mini black hole. Black holes have such intense gravity that nothing, not even light, can escape. They swallow stars and defy common understanding. The idea that even a small one could be produced by the LHC is shocking. Could it grow out of control and eat through Earth's crust? Some say any black hole created would be unstable and disappear quickly. But even that small chance has people scared, curious, and amazed. To understand how the LHC could make a black hole, you need to understand the basics. When protons slam into each other, they generate so much energy that space and time might bend. Imagine a trampoline, drop something heavy on it and it bends. If the object is heavy enough, it could make a hole that pulls everything nearby into it. That's sort of what could happen at the LHC on a quantum scale. There's a theory that extra dimensions exist, ones we can't see. If they're real, the LHC could tap into them and form a tiny gravitational anomaly, a miniature black hole. This idea has drawn attention from scientists, including Stephen Hawking. He theorized that at very high energy levels, the Higgs boson could become unstable, potentially triggering vacuum decay, a catastrophic chain reaction that could destroy the entire universe. Sir Martin Rees, a well-known cosmologist, also voiced concerns. In his book about the future, he described a worst-case scenario where a failed experiment could destabilize the vacuum, affecting spacetime itself. He admitted it was unlikely, but warned the stakes are enormous. CERN researchers have tested extensively, reviewed theories, and taken safety precautions. Brian Cox has reassured the public that the LHC's energy levels are normal for Earth and that the chance of creating a stable black hole is incredibly small. Even if one were created, scientists believe it would evaporate almost instantly in a burst of energy, a phenomenon called Hawking radiation. Still, some worry the LHC could open a portal to another universe. Most scientists don't believe this, but the idea has sparked fear in the public. The media sometimes amplifies these concerns, adding to the unease. But how did this idea start? The concept of extra dimensions isn't new. According to string theory, there may be more dimensions than the ones we perceive. They could be hidden but reachable in extreme situations. The LHC might be the key to unlocking those doors. When protons crash at unprecedented energy levels, they could create ripples that probe these hidden dimensions. If they exist, the LHC might expose them. However, it's important to know that despite the LHC's power, there's no evidence that it will open a door to another universe, especially not one that poses any danger. Still, the mystery of the unknown, and the weirdness of quantum physics, keeps people intrigued. Should we be scared of the LHC? It's easy to be influenced by dramatic headlines. But CERN scientists understand the risks. They've taken steps to ensure their experiments are safe and are constantly monitoring everything they do. The potential benefits of this research, like understanding the universe better, discovering new particles, and solving dark matter, far outweigh the fear. It's not about showing off, it's about pushing the boundaries of human knowledge. Like any major step in science, there are dangers. And we should be cautious and respectful. The Large Hadron Collider is where science reaches its cutting edge, where theory meets experiment. Its ability to answer questions about the universe, like where mass comes from and what dark matter is unmatched. Even with safety checks, the LHC stirs awe, mystery, and fear. The scale of the machine and the energy it creates are mind-blowing. Each new experiment brings new possibilities. Most scientists believe the LHC is safe. But uncertainties remain. What if something strange happens? The conditions of the Big Bang is thrilling, but it's also a heavy responsibility. Every particle collision at the LHC is a step into the unknown, a chance to glimpse something completely new, maybe even something that rewrites what we thought we understood about the universe. But that means the scientists behind the LHC aren't just smashing protons, they're pushing the boundary between knowledge and mystery. Even though fears of black holes or vacuum decay are mostly theoretical and extremely unlikely, they show how massive the stakes can feel. It's not just about finding new particles, it's about realizing how much we don't know. Each discovery comes with more complex questions. Why is gravity so much weaker than the other forces? Is dark matter made of unknown particles the LHC might one day uncover? Could there be hidden dimensions influencing our world in ways we can't perceive? That's what makes the LHC so special. It's not just a machine, it's a portal to the most extreme frontiers of science. It's a place where imagination meets data, where equations are tested in billion-dollar experiments. It's a symbol of how far humans are willing to go to understand our place in the cosmos. And as the LHC gears up for more powerful runs in the coming years, with upgrades pushing the boundaries of energy and precision even further, one thing is certain. It will keep challenging our understanding of reality, offering glimpses into the deepest layers of existence. Because in the end, the LHC isn't just asking, what is the universe made of? It's really asking, what are we in this universe? And that's a question worth every risk, every proton, and every crash. Things like mini black holes cause concern. Physicists such as Stephen Hawking issued dire warnings regarding what could happen, such as vacuum instability. Even though the likelihood of these things is low, the thought of them makes the public scared and interested. For some, the LHC is a symbol of people trying to control nature, a desire to control the forces that run the cosmos. For others, it's a tool to see the basic nature of reality. Trying to learn comes with results. Like with all science, there are ethical problems and risks we don't see coming. What takes place when we have the ability to see the universe's deepest secrets? Should we stop and think about whether we're ready for the answers we might find? Beyond the known scientific risks and thrilling possibilities of the Large Hadron Collider, LHC, its existence also brings up profound philosophical questions. The scale and complexity of the LHC force us to rethink not just what we know, but how we know it. Scientific discovery has always pushed the boundaries of human understanding, but the LHC operates on a level where observation becomes abstract, and data has to be interpreted through highly complex mathematical frameworks. This raises a unique challenge. When evidence is buried in layers of quantum uncertainty, how do we distinguish what's real from what's theoretical? Furthermore, the LHC emphasizes the increasingly collaborative nature of science in the modern age. No single country could fund or build a machine of this magnitude alone. It's a collective achievement involving thousands of researchers, engineers, technicians, and students. They come from all over the world, working on a common goal. That spirit of international cooperation is something rare and valuable in a time when political tensions often divide countries. In a way, the LHC is not just a scientific endeavor, but an emblem of global unity for the sake of knowledge. Another point worth considering is how the discoveries made at the LHC might influence other scientific disciplines. For instance, breakthroughs in understanding subatomic particles can bleed over into improvements in chemistry, nanotechnology, materials science, and even medicine. The foundational knowledge from these experiments could lead to better imaging techniques, faster computing, or novel energy sources. Historically, fundamental science has often paved the way for unexpected technological revolutions. When scientists first started studying quantum mechanics, they had no idea it would someday lead to microchips and smartphones. The sheer amount of data generated by the LHC is another marvel in itself. Each second, detectors collect information from millions of particle collisions. To explain everything, CERN has had to develop some of the world's most advanced data processing systems and algorithms. This demand for high-speed, high-volume computing led to the invention of the World Wide Web at CERN in the 1990s. Today, their computing infrastructure spans the globe, linking supercomputers across continents. This immense data analysis capability not only helps in physics but sets the stage for breakthroughs in artificial intelligence and machine learning. There's also an interesting cultural angle to the LHC. Because it deals with concepts like dark matter, antimatter, additional dimensions, and the very beginning of the universe, it has captured public imagination in a way few scientific projects have done. It frequently appears in books, films, TV shows, and internet lore. This media exposure is a double-edged sword. On one hand, it gets people excited about science. On the other, it can spread misinformation or fuel fear-based narratives. Still, the fact that individuals are even discussing quarks and bosons over dinner conversations shows how powerful the LHC's impact has been beyond academic circles. Meanwhile, ethical considerations continue to evolve. Should there be a global framework for regulating high-energy physics experiments, just as there are international treaties around genetic engineering and nuclear weapons? Some argue that pushing the limits of reality at the quantum level should come with checks and balances. The concern isn't just about catastrophic failure. It's also about responsible stewardship of knowledge. Once a discovery is made, like a new state of matter or a method for altering the vacuum state of space, who decides how it's used? At the same time, it's critical to acknowledge the LHC's role in education. The facility supports countless PhD programs, internships, and research fellowships. It's not just building our knowledge base, but training future generations of scientists and engineers. These individuals often take their skills into other industries, helping to advance innovation across the board. The LHC's influence spreads far beyond physics, into computing, communications, electronics, and even finance through complex modeling techniques. What also makes the LHC unique is its humility in the face of the unknown. Unlike some areas of science that are effective with hypotheses and expected results, particle physics accepts that not every experiment will yield definitive answers. Many discoveries at the LHC have taken years to verify and are still being debated. This patient approach to uncertainty is a vital lesson in a world increasingly obsessed with quick results and instant gratification. Lastly, the LHC challenges our understanding of the universe not just in scale, but in purpose. Are we trying to decode the universe because we can, or because we believe it holds meaning for us? Are we driven solely by curiosity, or is there an underlying hope that through science we can answer age-old philosophical questions about existence, purpose, and even consciousness? Regardless of whether the LHC ultimately reveals the secrets of dark matter or extra dimensions, its real value may lie in what it represents: humanity's unending quest to explore, to ask, and to understand. It reminds us that the biggest leaps often begin with the smallest particles, and that even when we peer into the fabric of the universe, we are also evaluating ourselves. As the LHC continues its work, it stands as a testament to human ingenuity, persistence, and vision. Each new run of experiments adds another layer to our understanding of the universe, sometimes reinforcing existing theories, other times challenging long-held beliefs. The challenges are not just scientific, but also practical. Maintaining and upgrading a machine of such scale requires constant innovation. New detectors, improved magnets, and cutting-edge cryogenics are just a few of the technologies developed or refined through the LHC program. These advancements often find their way into industry and society, creating a feedback loop between fundamental science and real-world applications. Moreover, the LHC has become a symbol of scientific transparency and open data. CERN's commitment to sharing results and methodologies with the global community allows researchers from around the world to contribute, replicate, and expand upon findings. This model of open collaboration may well shape how science is conducted in the 21st century. Public engagement is another evolving aspect. Through documentaries, social media, museum exhibits, and educational outreach, the LHC isn't just a machine behind closed doors, it's an invitation for everyone to be part of a journey into the unknown. It's science that doesn't only happen in a lab, but also in the minds of curious individuals who dare to wonder. As future upgrades like the high-luminosity LHC come into play, the questions grow deeper. Will we finally detect supersymmetric particles? Will we uncover evidence of hidden dimensions or quantum gravity? Or will we instead stumble upon something completely unexpected, something that rewrites physics as we know it? Whatever the outcome, the story of the LHC is not just about collisions and detectors. It's about ambition and humility, imagination and precision. It's about standing at the edge of what we know and asking the most human question of all, what lies beyond?